Alright, today we're going to be talking about the ambiguous case using the law of signs. And this happens when you're given two sides and then a non-included angle, so that's side-side angle. And that results in many possible cases that you need to consider when solving these triangles. So we can see here from this graphic how that might work out. So we're given this angle right here and then our two sides. So we don't know the angle between them or this angle over here. And that results in different possible triangles being created. So you can see that we could have a triangle right here. We could have this bigger triangle over here. We actually could have a situation where there's no triangle at all if this leg ends up being too short to meet this side down here. So we need to use the law of signs to figure out if the triangle exists, if there's exactly one triangle, or if there ends up being two triangles. So we can talk about the specific cases that occur when given side-side angle. So the first one is when we only have one triangle created. Okay, so let's say we have our side B, and then we don't know this bottom side. And we know this is angle A. And then we use a law of signs and we find that our other side A meets our third side right here, so then we only have one triangle created. The second possibility is that there end up being two triangles. So even when we're just given side-side angle, we could still end up with two triangles, and then we'd have to solve both triangles. So two triangles is our second case. So here let's say we have our side B again, our unknown side, our given angle A, and then we can find that this side length A could meet right here and create a big triangle like this, or it could actually go this way depending on what we find this angle measure to be. So then here we have two different triangles. So we have our smaller triangle and then we have our big triangle. And we'd have to solve both triangles in this situation. And then the last possibility is where we end up with no triangle. Okay, so we're still given a side, and angle. So again, we'd have our side B, our unknown side, our given angle A, and then we'd find that this side right here would be too short to create a triangle, so we would have no possible triangle existing. So the best way to look at these is to just solve different problems and see how the cases work out. So for this one, we're given that this angle right here is 40 degrees, and then we know that B equals 17, and we would know that side A would be somewhere over here. We don't know if it's going to reach our third side or not. So we need to first solve for angle B because of what we're given. So we know we can do the law of signs. So we would have sine of 40 over 5 equals sine of B over 17. So here we're solving for what's going to be, or what would be this angle, but we're not sure what it is right now. So once you put that in your calculator, take a minute, type that out in your calculator and see what you get. Okay, so you actually will end up with an error on your calculator. So you didn't do anything wrong, but that means that this triangle doesn't exist. So you'll end up with some sort of error. It might say like domain error or something like that. So that means that side A over here is not long enough to reach the third side of the triangle. So therefore this is not a triangle. And then we're done. And that's all we have to say for this one. Okay, so those ones are pretty easy, but let's look at this next example. So this one again, we have that this angle is 40, and we have B is 17 again, but instead of A being 5, we have A equaling 12. So let's first solve for angle B, just like we did last time. So we have the sine of 40 over 12 equals sine of B over 17. And once you put that in your calculator, you should end up with B equals 65.6, which will round up to 66 degrees. Okay, so from there we can figure out the third angle. So we already know that A equals 40 from our given information, and then let's figure out what C equals. We know that's going to be 74 degrees. So once we get to this point, we need to stop and check if there's another triangle that could exist, and the way we're going to do that is see if the supplement of the angle that we solved for, so angle B, is small enough so that another triangle could exist. So we're going to find the supplement of B, which we know would be 114 degrees. So let's say that equals B2. And then if we take 114 plus our given angle, because we know angle A has to be 40, we know that will equal 154 degrees, which is less than 180. Okay, so that means that we could have another triangle, because we know that the angles in a triangle sum to 180 degrees. So because of that, we can say yes, there are two triangles. Okay, so here we have B2 equals 114 degrees. So let's find the other ones. So we know that A2 is still going to be 40 because that's given to us. And then in our second triangle, angle C2 is going to equal 26 degrees. Okay, so now we have all the angles for both triangles, and we need to figure out the side lengths of both triangles. So let's go back to our first one and figure out the side lengths of those. So we're going to use the law of sine again to figure out our side lengths, just like we've been doing. So we have the sine of 40 over 12 equals sine of 74 over C, because we need to figure out side C. And once you solve that, you will get C1 equals 17.9. And then we already know that B1 equals 17 and A1 equals 12 from our given information. And then we need to go back and find the sides for our second triangle. So that would be sine of 40, again, over 12 equals sine of 26. So this is our angle C for our second triangle, over C2. And once we solve that, we'll get C2 equaling 8.2. And then still B2 equals 17. And A2 equals 12 still. Okay, and those are the three sides of our two triangles. So let's just draw what those triangles would look like so we can kind of see how this worked out. So our first triangle ended up looking something like this. So this was we actually had angle C up here and then B over here based on our first diagram. And then this was 40, 74, and 66. This was 17, 12, and 17.9. Okay, and then our second triangle actually would look something like this. And this was A, B, C, and we found B to be 114 in this case. Angle A was still 40, and angle C ended up being 26. And then we had 17, 12, and then 8.2. Okay, so you can see that there's two completely different triangles being created, so you need to make sure that you check for both in each time you're solving for the triangle. Alright, so let's move on. Do number 3. So number 3, we're going to start the same way. So we have angle A here equaling 64, B equals 8, and then our side with an unknown angle equals 10, so we don't know where this is going to end up, but this side's 10. So we're going to solve using law of sines. So we have the sine of 64 over 10 equals sine of B over 8 because of what we are given. And we'll find here that angle B equals 45 degrees. So again, we need to stop and see if there's going to be another triangle. So the way we're going to do that, again, is use the supplement of angle B. So we have the supplement equaling 135 degrees plus our given angle, 64, which equals 199. So here, this is greater than 180. So we know that a triangle with sides, or with angles 135 degrees and 64 degrees cannot exist because that's too big. So therefore there's only one triangle possible. So now that we know that, we just need to solve for the 3 sides of the triangle. So we have already that angle A equals 64. We found B equaling 45, and then we can solve for C equaling 71. And to find our sides, we're going to do the sine of 64 over 10 equals sine of 71 over C. And when you put that in your calculator, you should get C equals to 10.52. So we have A equals 10, B equals 8, and C equals 10.52. And that's our only possible triangle for this problem. Alright, and then our last problem here, I want you to try this one on your own. And we will talk about it in class tomorrow. So first, when you're doing this, make sure that you check if there's 2 triangles before you just solve for one and then stop. Alright, so make sure you check and then see if there's 2 triangles and finish the problem on your own. And that concludes our 9.11b notes.